All right, projectile problems. So this is a shortened version of quadratic equation story problems that's just on projectiles that I chose to do this year. We're going to go through each one and draw a quick picture and just spend a lot of time on this. And I might actually add some information that's not being asked just so that we can be prepared for anything. So this is the height in feet of a bottle rocket is given by, and this is function notation, the h of t. So the h is height, and the t is the time. And so it's 160t minus 16t squared, where t is the time in seconds. So this is time in seconds. And then I believe this height is in feet, even though it's not in the problem. So I'm going to explain the different parts of this function to you. So this is function notation. It's like having f of x, except they have h of t. It does not mean h times t. So the different parts of the equation. This part right here, the negative 16, gravity, if you're looking in feet per second, this is the effects of gravity. So gravity pulls down 16 feet per second squared. It's an acceleration, so it has the seconds squared. If you were in science, that would be 9.8. 9.8, but technically gravity is 32 feet per second squared, and we use half of it in this equation. There's some calculus to explain why it's half. So if we were doing in meters, it'd be 9.8. You divide it in half, use 4.9. So you're going to see negative 16 in all of these equations. That's basically the gravity pulling it down, which is why there's a minus. The 160 is your launch velocity. And because it is positive, that means that you're launching it up. So it is being launched up at 160 feet per second. And then this is gravity pulling it down. And they use half of gravity, and it's kind of complicated. I didn't understand any of this until I took calculus in college. So I won't go too in-depth with the physics part of it, but basically the gravity part pulls it down, and this is our launch speed. And we are starting from the ground. They're shooting off the bottle rockets from the ground, so I don't have any original height that I have to deal with. It wants to know how long it will take for the rocket to return to the ground. So we're going to try to find t. When it's on the ground, what is your height?
Nothing. Zero.
Nothing, 0. So what we're going to do is we're going to take this equation and we're going to make it equal 0. And I could put the 0 on the other side. I'm just directly putting in where it has the height over time. So this whole thing sometimes is just written with an h. They got fancy with function notation, but we're going to put 0 in there. And then we can actually solve this by factoring, which was our last lesson. So when I look at this, it's not the kind that I would solve with the x. It's the kind that I'm like, okay, I think 160 and 16 have a greatest common factor of 16. 10 doesn't go into 16. So I could take out, I could make this 16 times 10 times t, and I could make this 16 times 1 times t times t. And so we get to take out a greatest common factor. So 16 is the greatest common factor of 160 and 16. And I could also take a t out of both terms. So the 16 and t are going to go on the outside of my parentheses. And then what's left to go on the inside?
10 and 1.
So I have 10 minus 1t. So I'm just going to go ahead and call that t. You can keep the 1 if you want to. And so I have two pieces here. This times this in the parentheses makes 0. So that means either 16t equals 0 or 10 minus t equals 0, which is what we learned in the last lesson how to do. And then we just solve each of those. So how do I solve 16t equals 0? How do I get the t by itself? Divide by 16. It's not going to do much though, is it? I'm going to get t equals 0. And then over here, I can subtract 10. This is sort of the long way, but it's okay. I have negative t equals negative 10. Divide by negative 1. We get t equals 10. So how is this going to work if it's hitting the ground twice? Well, let's think about this if we have a graph. So I'm just going to draw. I'm not going to get fancy. I'm just going to sketch this really quick I'm going to put time on my x-axis because that's the independent variable. So I have 0 here, and then I'm going to put 10 over here. When I shoot this bottle rocket up, if over here I have the height, so it might go straight up and come down, but time is passing, so it's still going to look like this. You're going to get what's called a parabola. It's going to go up, and it's going to come back down. And even this is not its placement on the ground. This is the height over time. So it's going up, 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 and then coming down, 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 but we show it as time passing. So what they're telling us is it started on the ground on 0, so that's not the one we want. And then it's on the ground again at 10, that's the one I want, so 10 seconds. Okay, and then let's see what else they ask us. So there's another question. That was the first question. How long will it take for the rocket to return to the ground? We solved that. And when we did it, it showed us both times that it was actually on the ground, which makes sense. But we can throw out the one that we don't need. We already knew it started on the ground. We need to know when it's going to end on the ground. So this says, what is the height after 2 seconds? Well, this is your height equation over here. All we're going to do is substitute 2 in. So we would just do h of 2, which is 160 times 2 minus 16 times 2 squared. And you could put this all into your calculator, and it comes out 576. So that'd be 576 feet. So this is 2 seconds to be right here. That's saying wherever that meets, that's 576 feet. And we're going to learn here in a minute how to figure out what this maximum height is, how high it goes. We're just kind of easing our way into it. So they could ask you just to put numbers into the formula to see if you remember how to use a formula. And then they also could ask you to figure out when it hits the ground again. So I just thought this was, because we were running out of time this year, this would be a really good way to introduce you guys to the idea of how quadratics can be used and how we could use our factoring a little bit. And then next year we'll go in a whole lot more depth, and we will also look at different kinds of problems other than just projectiles. But these are kind of fun. All right, so it says a foul ball leaves the end of a baseball bat and travels according to the formula h of t equals 64t minus 16t squared, where h is the height of the ball in feet and t is the time in seconds. So here's that negative 16 again for gravity. So they hit the ball at 64 feet per second. It's not usually how they time a baseball. They usually do miles per hour, but I don't feel like doing that conversion right now. So it says where height is the ball in feet and t is the time in seconds. So how long will it take the ball to reach a height of 64 feet in the air? So now they're giving us a height of 64. So instead of it being on the ground, we're looking for where it's going to be at a height of 64. So I'm going to have 64t minus 16t squared equals 64. Now there's a whole lot of stuff that we kind of need to rearrange to do this. The first thing I need to do is move this 64 over to the other side. We can only use factoring or any of the other methods that you haven't learned yet if this side is 0. And so what we're going to do is we first set it equal to 64. Do you guys get why? Because we're trying to figure out for how long it's at a height of 64 feet. And then so what we're going to do is, first of all, I'm going to rearrange this and put the negative 16t squared in the front because that's the way we're used to seeing it, and put plus 64t after that. And then I want to move this 64 over here, so I would subtract 64 and then subtract 64 from both sides. So I'm going to go ahead and put minus 64 there. All I did was move this 64 to the other side so this can be 0. This has to be 0. If you're going to factor this to solve, it has to be 0 because we're using what's called the zero product property, and that's the only way that factoring will work for this. So take a moment and make sure you get how I moved everything. And then we're going to factor this. So I want to look at my numbers. I've got 16 and 64 and 64. 16 goes into 64 4 times. So I could write this as -1 times 16 t and t and then 4 times 16 times t, and then 64 would just be 4 times 16. So I'm going to take a 16 out of all the terms and put that in front, and then I have negative t squared plus 4t minus 4, and we're a little bit closer. Now the other problem that I see is in order to factor this using the x and the method that we're used to, I cannot have a negative here. So there's this cool thing where I could just take a negative 1 out of all the terms. So what I'm going to do is I'm going to put the negative out here on the 16.
Hold on.
Shouldn't you have put
Okay.
T in there?
Nope,
Oh,
this one
that's
doesn't
the
have
one.
one.
That's the one.
Yep, so I only had 16 on all the terms. So I'm going to pause because we're still trying to write. So we took a 16 out of all the terms, and I had negative t times t is negative t squared, plus 4 times t is 4t, and then minus 4 over
What do you
here.
have on your thing?
Okay, so now what I'm doing is I cannot have a negative here and factor it. So I'm going to move the negative to the outside. I'm going to undistribute a negative, which makes this t squared. It's going to change all the signs on the inside. This is a trick. So I'm going to have minus 4t and plus 4. And then this piece down here that's in the parentheses can be factored this way, 4 and negative 4. So multiplies to make positive 4, adds to make negative 4. So that would be negative 2 and negative 2. So I'm going to have negative 16 times t minus 2 squared, because I don't feel like writing it twice, equals 0. Now normally we have two pieces. This actually is both pieces. You cannot make negative 16 equal to 0, so you can just throw that out. That's not part of your answer. I can take t minus 2 and make it equal 0. And so then if I add 2 to both sides, then I get t equals 2. And technically you get that twice because you have t minus 2, t minus 2. So I feel like something's not right. Okay, so it hits that at 2 seconds. Oh, I know why.
Oh no.
So I'm going to go through a little bit more information and then we're going to come back to this because I meant to start this a little differently than I did. I meant to add another piece. So hold on to that thought. How long does it take the ball to reach a height of 64 feet in the air? If we take a look at when this hits the ground, this is going to be... actually, we can go ahead and put seconds on this. It takes 2 seconds for it to reach that height, so that's okay. But I also want to use this problem to do another problem. So what we're going to do is figure out when this hits the ground like we did on the first one. So I'm going to set it equal to 0 and just have the original equation 64t minus 16t squared. So this one would be a little bit easier to factor because I could do 16 times 4 times t and 16 and 1 and t and t, and then I could take a 16 and a t out to solve this problem, which is a little bit extra that I'm adding on. Okay, so is everybody following so far? So we're taking out the 16 and the t, and then what's left is 4 minus 1t, so just be 4 minus t. So this is going to tell us when the baseball is on the ground. So I would have 16t equals 0. We divide by 16, so t equals 0. And I have 4 minus t equals 0. And there's a shorter way to solve this. You can actually add t to both sides. It's been a while since we've talked about that. But then I don't have to like subtract the 4 and then divide. So I'm getting 0 and 4. And they did not give us an original height of the baseball. I think realistically it would be 4 feet-ish off the ground. We're not thinking a lot about that. So for this, they're assuming the baseball starting on the ground. We know that's not exactly true. But it's on the ground at 0, and it would come back at 4. If they'd given us a height, we could adjust this a little bit. And so that 2 seconds that we found that it would reach a height of 64 feet, we find that that actually is the maximum height. That's as high as it goes. That's the top. So it's kind of cool, and I wanted to add that on just so you guys could see how I just worked that out. So the 64 feet they were giving us over here has to be the height for that too. So it just kind of worked out that way. But they're making a lot of assumptions here, and I'm going to show you how to take care of
I
that.
don't understand any of this.
Okay, so we're putting 0 in because we want to know when it hits the ground. The ground is 0. We're factoring this. Did you follow the factoring?
Yeah.
So you missed the lesson on where we take this and solve the equations, so it's normal that you would be a little lost on this part. Just try to stay with me, okay? You have a lesson to make up that would probably help you understand this. All right, so on the next page, a model rocket is projected straight upward from the ground.
What's the answer?
Oh, so it's 64.
Oh.
So the maximum height is 64. So I was just showing you guys that that's, and then so it hits the ground. So it hits at 4 seconds, if that's the question that we're being asked. Yep, sorry, I was off the screen. So it hits at 4 seconds would be the answer to that question. And then if they asked you the maximum height for this question, it would be 64, and it happens at 2 seconds.
Okay, yeah.
So we're going to add on to this idea here in a minute, but I just thought it was kind of cool that they actually gave you that midpoint where it was at the top. Okay. So just keep watching. We're going to do 2 more. And it's not going to change tremendously. So just keep watching, okay? A model rocket is projected straight upward from the ground level according to the height equation. Height equals, so this time instead of h of t, they just used h. So instead of function notation, they're going back to more like a normal looking equation. There's the negative 16t squared, so that's your gravity pulling down. And then I have plus 192t. And it says t is greater than 0, so we're having positive time. Where h is the height in feet and t is the time in seconds. At what time is the height of the rocket maximum, and what is that height? So I think what they're saying is, when is it going to reach the maximum height, and what is that height? So we're not going to have that cool thing where it just falls out already. We're going to go through this process. So first we're going to find out when it hits the ground, because it should, if it starts at the ground. So let's talk about this first. It starts at the ground, and it hits the ground.
I have a question.
Yes.
Didn't you say you didn't learn this until you were in calculus?
No, I said I didn't learn where the negative 16 comes from until calculus. I learned this probably the same time you did, sophomore year of high school. So if it starts on the ground and ends on the ground, this maximum height is going to be half the time between where it starts on the ground and ends on the ground, right? So there are other ways to do this, but based on what you guys know how to do, we're going to figure out when it hits the ground again and then go to half of that time. So we're just adding a little piece onto what we already did. So when it hits the ground, what is the height?
Max.
192.
When I'm on the ground, what is my height? 0. So I'm going to put 0 in. And that's good because we need 0 in order to solve this anyway. All right, so, 192. I wrote 19. So 16 does go into 192. So I can write this as negative 1 times 16 times t times t. And then I can write this as 16 times 12 times t. I did have to do a little work figuring out it's 16 times 12, but it's worth taking a calculator and checking that really quick, because if you can factor that out, it makes it a whole heck of a lot easier. So I'm going to take 16 and t out of both terms. I'm still left with negative 1t, so that'd be negative t.
T plus 12.
And then plus 12. Yes. I was getting there. My brain just sort of took a little jog to the side. So if I solve these, so Keegan, here's the part that you missed. So I want you to listen really carefully. We just factored out the greatest common factor. You were here for that lesson. Okay, what we learned on Friday was that we can take this piece and set them equal to 0 and solve, and that gives me the answers to this up here that's equal to 0, because this times this is 0. If I'm multiplying and the answer is 0, that means the pieces somewhere in there have to be 0. So 16t equals 0 is how I set up the first one, and negative t plus 12 equals 0 is, so you just take these pieces and set it equal to 0. And then we're solving equations like we have solved before.
T equals 0, T equals 12.
Okay, so he's telling me t equals 0, so let's just double check. So if we divide by 16, I do get 0. So we started at 0. We already knew that one, so that one's not super helpful. Over here, I'll go through the process the way you guys are used to seeing it, even though it takes longer. If I'm solving for t, Keegan, what would I do first?
Add the t.
Okay, you can add the t. Okay, so if that makes sense, we'll do that. So we get 12 equals t. That means it's going to hit over the ground here at 12. So if it asked us when it hit the ground, that would be my answer. And this is my time, and this is seconds.
Don't you divide
Okay, so we're going to do this midpoint because we want to know when it's going to reach its maximum height. So half of 12 is 6. So it will reach it at 6 seconds. And then to figure out what this height is, I'm going to put 6 seconds back into this equation. So I'm going to do height equals negative 16 times 6 squared.
Now, how'd you get 12?
Because from right here.
No, like, how'd you get to the number 12? Like, all the way back up there. How did you get down to 12, please?
16 times 12 is 192.
Oh, okay, so you divided it.
So we just took that out. That's just figuring out. I used a calculator to figure out if one. I actually took 192 divided by 16 to see if it worked, and it did. I got 12. So that's just seeing if I could take that out. Okay, so I have negative 16 times 6 squared plus 192 times 6. So I'm just taking this 6 that we just found here, because that's when it's going to be at its maximum height, and I'm putting it in the equation, because the equation gives us height. And then I would type this into my calculator. You can do it all in one step if you want. And I find out that that height is 576. So my final answer is going to be 576 feet at 6 seconds. So that answers both of the questions. And then if you want to put this 576 feet over here on your graph, just so you can be thinking about that, that works. So we're doing the height versus the time on all of these. Okay, so on a lot of these, you may have to go back and put something into the equation. That's okay. Now on the last problem, we are going to add in what if something doesn't start on the ground. What if it starts off the top of a building or something like that? Okay, so we're going to look at that next. This is the height h in feet of a projectile launched vertically upward from the top of a 96-foot tall tower when time is 0 is given by h equals 96. That's the original height, plus 80 feet per second times a second. So that's accounting for the velocity that you shot at, 80 feet per second. And then this is your gravity pulling down, negative 16t squared. How long will it take for the projectile to strike the ground? What is the maximum height that the projectile reaches? So we're going to solve all the different kinds of problems. Now, I don't like the fact that they put the t squared on the end. So when I do this, I'm going to put 0 in for height because we're looking for where it hits the ground, but we're going to rearrange. Okay, make sure you're watching me now. I'm going to rearrange this and put the negative 16t squared in the front. I'm going to put 80t in the middle. It's actually already in the middle. And put plus 96 on the end. The reason I am doing that is because normally when we're factoring, they're going to have, it's called descending form. They're going to have the t squareds, then the t's, and then just the numbers. So all I did was rewrite this in a different order. Is everyone cool? Okay, now I'm going to see if I can take negative 16 out of both of these. I can because I checked this ahead of time. So let's go ahead and do that. This would be negative 16 times 1 and then t and t. 16 times 5 is 80. So I'm going to write that as 16 times 5 times t. And then 96 is 16 times 6. So I didn't have these memorized. I prepared yesterday, and I used a calculator to figure out. So anytime you have that 16, just see if you can take it out. I cannot take a t out because I don't have any t's in this last term. I am going to, well, I'll do this in 2 steps. This would leave me with, so if I take out the 16, Then I have negative t squared plus 5t plus 6. Okay, so everybody good with me taking the 16 out of all terms? Now, before I can factor and do my x, I cannot have a negative here. It only works with positives. So we're going to use that little trick I was just showing you a little bit ago. I'm going to undistribute the negative and stick it out here at the 16. And what that does is basically it divides everything by negative 1. So this would be positive t squared. The positive 5 would become negative 5t, and the positive 6 is going to become negative 6. So basically, and I'm going to write this in my notes, we just switched
Why did you want to do that?
all the signs. When we factor this first term, the squared term has to be positive. It will not work. So we switched it to positive, which is fine. I just took the negative out and switched all these signs. It's like you're dividing by negative 1. So if you want, switch all the signs.
What does that say? Oh.
Signs. We switched all the signs. And so that is a trick that you need to know because you have to do that a lot. Okay? It is a trick. I just taught you, and I did it on the other page also. So now this part that's in here, I can factor by putting negative 6 and negative 5 into one of our number puzzles with the x. So you need to know what multiplies to make negative 6, that adds to make negative 5.
3 and 5, 3 and 2.
3 and 2 doesn't work. So I have to have negative 6 and positive 1. Multiplies to make negative 6 and adds to make negative 5. 6s and 5s are the hardest because it depends on what the signs are. So I have negative 16 out here. I'm going to have t minus 6 and t plus 1 here. So the negative 16 out here, it cannot be equal to 0, so we just throw that part out. T minus 6 equals 0 we can do, and t plus 1 equals 0 we can do. So we're just taking the parts with t in them and setting them equal to 0 to solve. So I would solve this by adding 6, and that gives me t equals 6. I'm subtracting 1 here, and I get negative 1. It's kind of weird to think that time would be negative 1. But let me explain with a graph where that's coming from. Okay, so if I make a graph, remember we were not starting on the ground. We were starting from 96 feet in the air, and it's coming up and coming back down over here. So the positive 6 tells me it's going to hit the ground at 6. So what's the negative 1 for? If you continued this graph off into the negative side of the graph, which we're not really using because it didn't actually exist, this graph would hit at negative 1 over here. But that doesn't make any sense in our problem. We didn't actually launch the rocket from over here. We launched it from 96 feet. So we just throw that negative answer out. But it's good to have it on our graph because that's going to help us reason through the next piece. So how long will it take to strike the ground is 6 seconds. Huh?
I don't have room to write.
Okay, you're just going to have to find room and write small because we're not done. Or you could have actually glued this in the notebook and you would have the bottom of your notebook page. So you put it on your notebook page and write on the notebook page that would be below it. That's a way to solve this problem. All right, so remember that the maximum point is going to be halfway through where it's on the ground and on the ground again. Now, it never was on the ground the first time. But we're going to pretend that this negative 1 exists. Okay? So I'm going to figure out what's halfway between negative 1 and 6. And how I'm going to do that is I'm going to figure out what this total distance is. So from 6 to 0 is 6 and then another one. So the total distance is 7. The total distance is 7. So it's 3.5 either forward from the negative 1 or backward from the 6. So I have to go from here 3.5 seconds or this way 3.5 seconds. So let's just take 6 minus 3.5. That makes this 2.5. So that's when it's going to reach its maximum height, which isn't the answer we're looking for. We want to actually know how high it gets. So if I know it happens at 2.5 seconds, what can I do with 2.5 seconds? Put that into the height equation at the top. So h is going to equal 96 plus 80 times 2.5 minus 16 times 2.5 squared. And you could also use the one where we turned it around, but it's good to get back to the original. And all of this, you can legit just type it into your calculator, and it's going to give you 196 feet. So that's my maximum height. So on my graph, I'll just mark that so you can kind of have the whole idea. So at 2.5 seconds, it reaches its maximum height. So this was a number we're sort of throwing out, but it was important to be able to figure out where that halfway point was. There is another, actually a couple of other ways to do this that we'll talk about next year.